Okay, so welcome everybody. The class of today is totally focused on how to code illumination, the basic illumination. I will code half of the illumination, which is almost like half of the assignment that you have to do. So that's nice for you. Obviously, I understand that most of you are going to put this video on and try to copy the code, which is one of the ideas of having this. But remember that all the code is going to be on the slides. So I think the slides should be always the focus when you want to learn something. Because when I make code, live coding, like I'm going to do today, it's very likely that I will do maybe bad decisions about naming the variables, about placing the code in different places. So it's always better that if you want to do something, use the slides as the starting point, not the code I'm going to do. But I want to do the code as a way to show you that it's not so complicated to do the things we want to do. Like once you understand and move around the code, it makes sense, a lot of the things, okay? So this being said, I'm going to follow the slides for illumination and the ones that we already watched yesterday. And I'm going to skip to the parts of the code that we're going to be interested on, which are mostly about the shaders, materials, and stuff like that, okay? So here I have a copy of the whole engine. So if I execute it here, I'm going to put it in release for now, unless I need to debug anything. And so when I execute the code, this computer is a little bit faster than the other computer at the school, so it should be way better for most of the things. And also I can show you other cool things like inside, something I wanted to show you the other day, but I couldn't. So it compiles, it executes, and oh damn it, the window appears on my other screen. That's something I forgot. Because the window appeared on the other screen. Let me add one silly line, which I know doesn't make much sense for you now, but it could be easy if I do this. Set window position, I think. Yep. So this is the function that calls the OS and says, I want this window and I want it to be in this position. So I'm going to say 3000 by 200 pixels. And let me see if this works now, because otherwise I have to be moving the window every time I compile. And the window appears here. Whoa, I put the right place. So cool, we have the application. You can see it runs 60 frames per second, because this monitor that you're watching right now is a 60 frames per second blocked, so that means it cannot go faster than that. But I also have here this crazy number. These two letters US, I don't know if you can see them, they are microseconds. Yeah, microseconds. So you have seconds, and if you go 1,000 of a second, it's a millisecond. And now 1,000 of a millisecond, I think it's a microsecond. Maybe I'm wrong, but I think so. And the reason why I have this number is because it's more accurate to know this number than the frame per second. Frame per second usually don't tell you much, because if it's capped at 60, you don't know how much it's taking, much time. Also, this number doesn't come from the CPU, it comes from the GPU. I have a code, maybe I will show you later, that is measuring how much it takes to send to the GPU all the frame. And because of that, I can have a very accurate way to know how much work the GPU has to do. There's also another name here, which says DCS. DCS stands for draw calls. So it's more like saying how many times I have called the GPU to render something. This number doesn't take into account the interface, so this is only used for rendering things on this 3D space. So currently I have 24 render calls to render this whole scene, and the number of triangles is 20k, because it's 20,000 triangles, which I don't think is right, because I think there's more triangles here right now, but I don't know why it says 20k. And finally, I have information about how much RAM I'm using now. So from 8 gigabytes that has my GPU, it's using 2 gigabytes, but it's not me. I mean, I guess probably it's also other applications using 2 gigabytes, okay? And we can see that these numbers are right. For instance, the number of draw calls, because we have remember that we have these bounding boxes for every object, and we're testing if they are inside the camera. So that means that if I move the camera, I can see how the numbers change. So instead of rendering 20, I'm rendering less, and less. So you can see here, for instance, I'm only making 2 render calls. By the way, the 2 render calls I'm doing is one for the skybox and one for the grid right now. Okay, and you can see how this number is very small now because the time it takes to just do the to render calls is very few. I will fix it to make it sure that it's not always moving because this number is going to change so fast that it's hard to see. Okay, perfect. So as we say, our first goal is to start adding all the properties from the scene. First, we are going to add the ambient light, but we also have here the different lights. I didn't show you these things the other day, but if you click here, you can see all the properties of the lights, all the properties that we discussed the other day, besides shadows, that you don't have to worry about shadows because this is totally different, something we're going to do next week. But for now, you can see the type of light, like just point, spot, and directional. I'll forget about the unknown. I have to put it because of any reasons. The color of the light, the intensity. The intensity is just a scalar that I apply to the light. So you can say my light is red, for instance, if I go here, but that means the light is going to be 100, but maybe you want to have a lot of light, not just a little bit of light, and then you can multiply by, I don't know, by 10, so light will be 1000, okay? So I think it's always nice to have separated the color and the intensity because, well, you can play around better, but we could have make here like a vector 3 and then you can have all the things together. At the end, when you send this information to the shader, you just multiply color by intensity and you send it to the shader. Also remember that because colors here appear like a 0 to 255 value, but internally it's a float. Okay, so forget about this 0 to 255 because in the shader it's going to be floats all the time from 0 to whatever you want to. Okay, we have near distance. For now, I don't worry about this. Max distance, the thing about we talk about the attenuation, the light has a maximum distance that we want it to reach. And then in case of a spotlight, because this is a spotlight, we have a cone start and a cone end. We will see what's that later, okay? So let's start by making the most regular light, which is the point light, which is the simplest one. So for that, I'm going to close here. Let's go to the renderer. And here we have like for every node, I'm not going to use any code for sorting the meshes from like first the opaque one and then the alpha ones. I want you to do that for yourselves. I think that you have to play with the code. So there's going to be some part I won't do on the class. That doesn't mean that you don't have to do it. Okay, that means that I prefer you that you try to come up with a solution because otherwise all the things will be done by me. So for now, I'm going to focus on the function that we discussed the other day, which is render mesh with material. It's a function that receives where, what, and how. And then we are going to find a way to make it more interesting. So the other day in class, I did the emissive texture. And I say that because, sorry, emissive texture, I should have changed this. Sorry, I forgot it. To say here emissive and here the texture. Okay, so we have the albedo texture, which by the way I don't like to call it texture because it's a very generic name. I'm going to call it albedo texture. Makes more sense. So we have now the albedo texture and the emissive texture, but we know that these textures could be null and I don't want to have a null. So if it's null, I will assign a white texture. Okay. And because I'm going to do this a lot, I'm going to put this texture here, this white texture here, so at least I can reuse it. By the way, this get white texture doesn't do anything fancy. The only thing it does, by the way, I'm going to put it in full screen, which looks better. If you see here, what it's doing mostly is it checks if we already have the texture created. If it's created, it returns it. Otherwise, it creates a texture of 1 pixel by 1 pixel of RGB, also by type. And it's going to pass this data, and the data is just these 3 numbers, which is like all white. So it's a very simple function. I have also for black texture in case I need a black texture, and that's mostly it. And I don't know how to go back. 1 second. What's the shortcut to this? Is Control minus. Okay, so I got to do Control minus many times. Okay, so let's go back here. For now, let's forget about these textures, although it will be interesting that we put them. You have to put them on the assignment. For now, I'm not going to use them. So, and the shader. We have a shader called texture, but remember that shader was very basic. So what we want to do is create our own shader for illumination, okay? So for now, I'm going to call this shader, it's here. I'm going to call this shader, which is going to be a clone of this one here, but I'm going to call it, light. Yeah, just call it light. Okay. I was going to call it something different because in the future we'll have to change the name of this shader to something else, but I will do it when the time comes, so don't worry. So I take this texture shader fragment shader that uses the texture and everything. For the vertex shader, I keep using the basic VS. So remember what basic VS is, the basic vertex shader that multiplies the vertex by the view projection and the model and all those things that we did the other day. Nothing fancy here, so there's no need here to change this code. I think we're going to change it very few times, this shader, okay? Although there's another one here, which is a more simplified version that the only thing it does is whatever it comes as a vertex, it outputs as a vertex. Doesn't change the vertex at all. This is for when you want to send vertices already in a screen space, but that's not the case. We are sending it in local space, and we want to multiply it by the model to go to wall space, and we want to multiply it to by the view projection to go to screen space, okay? So, this being said, let's go to our light shader. Okay, and we are going to need a lot of information here. So first, we are going to need, this is going to be the albedo texture, and this is going to be the emissive texture. So you can see here that all these properties here, we can group them more like material properties, while the other things are more like global properties, things about, so this is related to the material of the object, while these ones are more related to global things that are on the scene, okay? So one of the things, sorry, if you change the name, always update the name. And this color is the color of the material. I don't like color. The color is very generic. It's like calling a number, a variable float or number. It doesn't help you much. But for now, let's go with this, and when we have a better name, we will change it, okay? So first, we start with the ambient, because this is the simplest one. So I'm going to go to the shader. Maybe using the control minus is not the best way to navigate the code. Yeah. Anyway, if I go anyway, I'm going to use the other trick, which is simpler. Sorry, I'm going to go to text light here. Yeah. So we were here, and instead of using this shader, now I have compiled the other shader called light, which is the one that is going to take into account light. And here we can start putting things like the albedo texture. Albedo texture. But remember that this could be null. And if you call this function passing null, it's going to crash the application. So as I said the other day, maybe it's good to have like a ternary operator here that say, hey, is this value different than false or null? Yes. Then we use this. No. Then we use the white texture. And be careful, because this only makes sense because we know that we're going to multiply the color by the texture. So if the texture is white, you multiply the color by white, it's multiplying the color by 1, so it's going to stay the same. So it's okay, you are not modifying anything. I'm saying this because last year there was people using the white texture for things that doesn't make any sense, like normal map. If there's no normal map, I send a white texture. Then you're sending like the normals, and every pixel are just a 111 vector, which doesn't make any sense, and it's going to produce strange artifacts. So only when we know that what we are going to do with this value makes sense to use this white texture. Could be the black texture, could be something else, okay? And the same with the emissive texture. And also I need to send the emissive factor. And as I said yesterday, we call it factor because in GLTF they call it factor. So I keep the name, but remember this is not a factor, this is a vector 3. Okay, you can see here it's a vector 3. Okay, so maybe emissive factor is not the best name to use here, but anyway. So because I have these variables now, always remember to catch them on the other side. So I have the color, the emissive is vector 3. Doesn't make sense to have a vector 4 for the emissive because we only have RGB, that cannot have alpha. And the rest, sorry, it's a factor also. If in any moment you see something strange, my code, you can throw questions on the chat and I will try to answer them, okay? So, we're saying that one of the global information that we need to take into account is the ambient light. So ambient light. This property is going to be a property we're going to well, put together. Like every time we render something, we're going to need to pass the ambient light. So maybe later I make a function for these things. Sorry, I forgot to change the ternary operator to the emissive. Thank you very much. I will check now. So remember that the global things are usually on the scene, okay? And the scene, by the way, we are not passing the scene here on the parameter, but the scene is also a global parameter renderer. If you go to render here, you can see that there is a scene here. So when you set up render this scene, the first thing I do is I copy the scene that you pass here on the scene. So that means if in any moment I need the scene, I have it accessible. Oops, ambient light. Okay, and this is called ambient light. Okay, just as a reminder or a comment, when we're working with shaders, we want to work very fast because, well, we want to render a lot of things, so the faster the better. And here you can see we are using strings a lot. String, 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 string. Strings are slow, okay? Always when we use strings, you have to think that this is it's like an array of a lot of values. So every time we use strings, it has to use them somehow, like reading every character to know something. In this case, when we pass a variable to a shader, every variable in the shader has something called a location. A location is just a number. Like the location 1 is, I don't know, U model. The location 2 is U time. The location 3 is U color. Okay. The problem is we don't know the location. So this function set uniform, what it does internally, so because I think it's interesting that you see this kind of functions, is going to call, well, many functions, but it's going to call this function get location. It's going to receive the name, the string of the name, and this function internally is going to search it using a std map, okay? An std map, well, it's fast because it's a kind of container made for seeking things inside, but still is not as fast as just, I don't know, using one single number. When it finds this value inside this map, it's going to return the location. If he doesn't find it, because maybe this location has never been searched before, then it searches the first time it's going to search it on the shader. This is the function to call the shader to say, can you give me this variable? And it's going to tell you and insert it. Otherwise, it's going to return the location from the last iteration. So it's more like the managers that we were talking the other day. So the first time it fetches, the next time you reuse the old one. Still, obviously, as I was saying, accessing constantly strings is slow. I mean, there are tricks to speed up these things, which is not using strings. Like you can have more like a struct, like one struct in C++ with all the variables inside, and then you only send that thing once to the GPU. Okay, but the problem is that syntax is a little bit tricky. And for now, I prefer that we use this kind of approach. Okay, I think it's better. Also, keep in mind that when you send something to the shader, if we change to another shader, we have to set up that thing again, okay? Because the data is stored per shader inside the shader. So that means that if we send, I don't know, the ambient light to one shader and we switch to another shader, we have to send the ambient light again. The nice thing about using structs is that you can send it once and say to the shader, it reuses the same struct when you change the shaders. So that code goes super fast in many cases. Maybe if I have some time, I will explain you how to do it. The engine supports it. There's a function specific for that. But for now, let's just keep you working this way. So I'm sending the ambient light, and now let's go to the shader here. So albedo texture, emissive texture. Sorry, you say before to change the ternary operator on the emissive texture. Sorry, yeah, you're right. So here, emissive texture. Thank you very much. And remember, every time we pass a texture to the shader, we have to specify it as slot. Okay, so here, first texture is the slot 0, and next texture is the slot 1. So you understand what the slot means, because maybe it sounds a little bit weird. Shaders have, like, I don't know, let's call it 16 slots, okay? And then when you have a texture in the GPU, okay, first you have to put the texture in one slot. Like you want to put this texture here, and this texture in this slot, and this texture in this slot. And then you're going to tell the shader, okay, if the user wants the texture called emissive, for instance, then it has to go to this slot over here. Okay, if you want to use it. So it's kind of strange, like this middle step. The reason is because assigning to the shader is very slow to these slots, and so this way maybe you can assign some textures once, and you have to assign it for every shader because you already know where they are, in which slot they are. So you can use you can speed up things using this kind of, I assign to one slot once, and then on the shader I'll have to say it's already here in this slot. But this is for speed up the rendering a lot, and I don't think we're going to spend so much time on these kind of things. So let's go with, we pass the ambient light and the properties from the material. So we have enough to add the material and the emissions as we did yesterday. So let's go back to our shader and do the thing we did yesterday, which is, I want to keep in mind that the discard, I try to put it as up as possible, okay? So when there's a situation where you're going to do, say, I detect now that I don't have to draw anything, if the sooner you do it, the better. So I'm going to start doing the computations here, because first, if I detect that the alpha is below a threshold, it means this pixel doesn't have to be rendered. The better I finish, the more time I save, okay? So here I'm going to say, okay, we're going to have a vector 3 that we're going to put 0. Be careful when you create a vector 3, you have to always initialize it to some value. If you don't do that, depending on the GPU and the architecture, it may happen that it's going to start with trash. It happened to me sometimes, like I make a renderer that I was assuming that when you create a variable, it was initialized to 0, but it wasn't. And in some systems worked well, but in other systems the image was like flickering with very crazy things, and it was because, well, the variable had trash inside. It was happening in Mac indeed. In Windows it was to 0, but in Mac it was not initializing into 0 automatically. So we have the light. So as we say, the amount of light always is the ambient light when we start the rendering. Okay, and then finally we have the color of the material. We call it albedo, maybe. I prefer albedo than color, as I said before, because color is very generic. And here we are going to say that the final color is going to be the albedo XYZ multiplied by the light. Okay, and because these are vector 3, sorry, I'm going to put vector 3 here. So the output is going to be color, but remember that color is a vector 3 and it's missing the alpha. So I'm going to put the alpha here directly from the albedo W. Okay, to access the fourth component, sorry, I didn't say, but in shader, remember that you can access the X, the Y, and the Z, or the W if it has 4 components, okay? But you can also access the R, the G, and the B, and the A. Sorry. So it's the same. So it's the same to put R than to put X. So it gives you this option because it looks more interesting. So I'm going to put the A because it sounds more like alpha. So to remember that this is, I'm getting the alpha channel from this texture, the albedo texture. Okay. So now, if everything goes well, I have sent all the parameters right to the shader. Let's execute it. And let's see what's going on. Remember that the shaders are going to be compiled during the execution and it's not crashing, which is good. And we can see it's very dark. Good. It means that it's using the ambient light, and I can see if I go to another ambient light, it's working. Cool. So the ambient light is there. Next step, emissive, no problem. We said the other day that the emissive shouldn't be multiplied by the material of the albedo of the object. So I'm going to add, by the way, I'm going to add here the emissive, and for the emissive, I'm going to just take the emissive factor, which is the color specified by the material, and I'm going to multiply it by the data that the texture has on that pixel for the emissive texture. Okay, and I only care about XYZ because this texture doesn't have an alpha channel. So that if we go back again to our application, now we should see that the lights are shining and this sign is shiny and the lights here are also shining. Okay, cool. So we have ambient and we have the emissive. Okay, now let's go to interesting thing, lights. Okay, so for lights, I'm going to need, oh, by the way, I did something that I didn't want to do. 1 second. I'm modifying this function, render mesh with material, and I'm going to make a clone of this function. I'm going to mesh with material, light. So it's going to be a function that's going to render this material, but I'm going to pass here. No, there you go. I'm not going to pass it. I'm going to make it a global. The number of lights, okay? Because where are the lights here? In the render now, if he wants to know where is every light, where it is. It's in the scene, inside the entities, but searching every time in the scene where are the lights is going to be very slow. So I'm going to try to optimize a little bit the code. So first, I'm going to make this function. I'm going to clone it. Okay, so let's go here, clone this function because I want to keep a function that only renders the object without any illumination. Okay, so this clone version of the function is going to be, let's call it the material light. Okay, and I'm going to go back again in this one to the texture one because I don't know, maybe in any moment, so I don't need to pass the emissive color and the texture and everything to the shader. But anyway, I can do it, but it's not going to be used now because, you know, this function is, this shader texture is not going to use it. So when we were calling before the render mesh with material, I'm going to say, no, can the mesh with material light, okay? But because we have two functions, maybe it would be nice to switch. Maybe I want to see only the how it looks with the regular illumination or like flat illumination or with lights. Okay, so I'm going to add another feature on my engine. I'm going to add a new property which is render mode. Okay, it's going to be an enum. That's going to be, we can use it if in any moment we want to debug. It would be nice to be able to switch to this kind of different render modes. So by default, we're going to go with flat because there is no any light, but also we want to have lights. Okay, so this way we can render with the flat or with the light mode. Cool. And by default, we need to have a variable to control that. So let's put here a variable render mode, and we got it render mode. Okay. So now, if in any moment I need to modify the render mode, I can modify this variable. I don't know why it's complaining enum render mode, and this render mode, and why it's complaining here, comma. I don't know, I think it's getting just silly. So in the renderer, when the application starts, I'm going to initialize this to a render mode flat. So all this hassle, why? Because now when I want to do the render mesh with material, like we have here, I can say something like, I don't know, switch render mode. So if the render mode case is a render mode flat, then we are going to use the old function that we were using. Oops. This function that is just renders the object without, sorry, not this one, the previous one, this one here, only the mesh with the material. But if the illumination mode is light, then we're going to render with this other one. Okay, I think it's light, no? Lights, sorry. Okay, so this is nice because now I can control if I want to render with one way or the other. And for now, it would be nice to be able to switch between the two modes. As an example, best way to switch is with using the keyboard. So for that, I will have to go to the application class and add a keyboard. But remember that we have a show UI method that we can add things to control here. So I'm going to add here a combo, which is the classical selector where you decide between different options. Okay, a combo, and this is going to be the render mode. So you can see here it says label, and I have to specify the current item. The current item is going to be render mode, the value, and it's expecting a pointer. Okay, it's expecting a pointer because this function can change this value, and because it can change this value, it doesn't want the value, it wants the direction of the value in case he wants to modify it. And then we have to pass here a string. It's items separated by zeros. Okay, so I have to pass here is the name of every element. So in his case was flat, then separated by zeros to make us a zero in binary. The escape character is /0. So flat and lights /0. You don't have to put this light 0 because automatically it always puts on the last character. And we have to say how many options we have. Is 2. So now what he's going to do is if this says 2, he's going to read first. When he finds a 0, he knows there's more, and he reads the next one. Be careful because with 3, he's going to read outside of this array, and it's going to crash the application. Okay, so this should be working, but it's complaining. Yeah, it's complaining because it says that the second parameter here is supposed to be a number. Okay, you can see here in this variable function is supposed to be an integer. But this here is not an integer, it's an enum, okay? So in these cases, you can always say, no, I'm telling you that this is an integer. This works because enums by default are integers. So when you create an enum by default, it's always using 32 bits. So it works. Otherwise, be careful because then you will casting, I don't know, if we imagine that it was forced to be an 8 bits variable, you're casting to integer, and that's going to crash the application. So let's try this tiny debug functionality that we have added to our system to see if we can control this render engine. So we have the flat mode, as we said before. Okay, but we can go to the rendering. Now we have a render mode, flat, and I can switch to the lights, and I can see in the light mode. Okay, so always when you're coding, it's nice to always keep expanding these widgets, because that means that you can have more, oh wait, there's something weird, I'm going to disable this, enable that, change that, so you can see what's going on easier, or you can debug easier if you have more control over what's going on. Okay, cool. So now lights. Remember, where are the lights? So lights are here in our scene container. Here scene, we have entities. Some of these entities are going to be lights. Some of the entities are going to be prefabs. When we are rendering here at the beginning of the function render scene, what we are doing here, you can see, is I'm walking through every entity. If they are not visible, I'm ignoring it. And if it's a prefab, I'm going to say, hey, call the node. Yeah, but I need to know how many lights do I have. I cannot just, if I find a car, render the car, and then I find a light, I should have rendered the car with light. So let's do it more beautiful, more clean. And something I can do is, for instance, say, hey, besides this, I'm going to need to have all the lights on my system here. Okay, let's call it lights. These are all the lights that we have inside the scene. But I also want to have the lights that are visible from the camera. So here we have every single light, and here we only have the lights that are inside the cone view of my camera. Okay, so we need to fill these parameters. When? Well, maybe when we are rendering the scene, or maybe when we do the setup scene, this function setup scene, I'm using it now for the cube map, but maybe we can use it also from here. So let's have something like, okay, I'm going to iterate through every single entity. Okay, if the entity is not visible, then I'm not going to do anything. It means this entity for me doesn't exist. And maybe here I can do something like extracting the render calls, the things I was telling you the other day. Maybe it would be nice to extract the render calls first, create a list with all the objects that I want to render, sort them, whatever you want to do, and leave it prepared when you want to start rendering. So, because previously what I have here is I'm walking through the data, I'm rendering along the way, which doesn't make any sense. First, I have to process the data, find the best way to use that data, and then I can use the data to render. Okay, so this approach was not the most efficient, not the most clean. Okay, so that's why I don't encourage you to do that. Also, when you set up the camera, I need the camera, and the camera is passed to the function, but I don't have it here. So the camera is here, but where is used? So I'm going to pass the camera because I think it would be nice to have the main camera. Yeah, but sorry, I'm spending the camera. Well, yes. Sorry, I don't need the camera here because this function is going to gather information. It's going to render anything. So because I'm not going to render anything, I don't have to have the camera. Okay, so I don't need to send it here. So it's going to say gather entities or process entities or something like that. So I'm going to work every entity. I want to know how to use it. So if it's a prefab, we will see what we will do. But if it's a light, this is more important, then I want to store this in lights. So I have this vector colored lights. I'm going to do a pushback, and I'm going to store this entity. Okay, and because this entity is of class base entity, I have to cast it to light entity. So I'm going to say no, this is not a base, it's a light entity. Remember that if you downcast, this is the downcast. I have a base a pointer pointed to a base class, but I know it's not a base class, it's a derived class. So I'm forcing the compiler to say, no, it's a derived class. So that means that, remember, this is a important reminder for you about memory allocation in languages like C++. So when you have a class like base entity, and then you, in this case, have 3 values here. So, sorry, in memory, it has 3 variables inside, okay? This class So if I make a new of this class, it's going to allocate this number of bytes. But if you make a class that which is derived from this one, like, I don't know, this is base class and I have the light class, the light class is going to append to this class the extra information. So here I have the base entity, and here is the light entity or the prefab entity. Okay, so it's the same amount of bytes of the base entity plus the extra data for the light entity. That means that when I have a pointer to the class, to this light entity, the pointer is pointing here. Okay, the pointer is not pointing here. Okay, because this is this base entity is part of the light entity. So when I have a pointer, it's pointed to the first byte of the base class. And that means that it's okay, because if I don't know this is a light entity, but I know this pointer is to base entity, I can read these values and it's fine. But if I know it's a light entity, I know that I can go beyond this area and start reading more value if I want to get information about light. Okay, cool. The problem is that if this class was not a light entity, the amount of memory I have allocated is only this part. Okay, so when I say no, it's not a base entity, it's a light, okay, then the compiler start reading here and you're reading out of memory. Reading out of memory, it's a crash. Okay, so that's why they say that, well, downcasting is very dangerous. You only do it when you are sure. I'm sure because I'm using the type I put on there, so it should be very safe. Other languages have better solutions to this problem. So I have an entity and I'm putting it here on entities. Be careful, because if you do that, every single iteration of this call to set up a scene is going to make these lights grow and grow and grow and grow, and it's going to explode your machine. So always clear this and say, no, we start from scratch. I don't want to have any element inside. Okay, so now the next thing is, after processing everything, I will have all the lights here. Maybe it would be nice also to have all the nodes separated in render calls in another STD vector. I would recommend you to do that, and also for the sorting and everything. For now, I'm just going to keep using this crappy code I gave you because I want to force you to do it better. Okay, so when I'm going to render now a node, I have the nice thing that I know that vector has all the lights. Okay, so cool. Then I can go here to this render material with light, and I can start trying to apply lights. So there's always two approaches to lights: or I pass all the lights at the same time to the shader, or I iterate many times over to render. I want you to do both. Okay, it's important that on this assignment you try to do both, and you will see why in the future, because there's situations where one can work better than the other. So it's better to have a system that can render using multi-pass, or you can render in single pass. Okay, so I'm going to make multi-pass because it's the trickiest one, and also because it's the simplest one in code. Tricky in the sense that you have to understand how to use it. And I expect you that you will do the other one for the first assignment. So what I'm going to do is I'm going to make a for loop, obviously, for as many lights as we have here now on the scene. So from 0 to light size. So now I'm going to render this object as many times as lights. Okay, if I did this, it doesn't make any sense, because it will render the car and the car and the car and the car in the same place all the time, and because it's rendered the same way, it's not going to change anything. I'm just putting more render codes, which doesn't make any sense. So first, I'm going to extract this entity. So from lights, okay, and now I have the light entity. Maybe I want to be careful of what kind of light it is. So if this light is of type what? Which one I'm going to start doing first? I'm going to start doing first the point lights. So if light type is of type light type is of type point, then I want to do something about the render, how do I pass the data or something like that. So if it's otherwise, if it's not a point light, I'm going to skip it. I don't want to render other lights now. I'm going to start rendering only the point lights, and when it works, I'm going to render the other ones. Okay, so we have this light and it's a point light. First thing we have to do is send the data about this light to the shader. Which information do I want to send? For point lights, it's very simple. You only have to send the light position. Where is this light? So light, And light position, by the way, you have to go to the model and get the, so it's the model, yeah, matrix model. Yes, no? Ah, no, sorry. You have to go to the node. It was the node? Root. To the root node, and then you have to go to the model of the node. And I assume that the global model is already updated of the light. So you can go to the global model. I'm not sure if it's updated. Sorry, I'm going to do something easier, which is I'm sorry, I'm silly. It doesn't matter if it's the global or the regular because lights don't have parents. I mean, if our engine we supported that lights can have parents, then yes. But in this case, lights are entities, and entities don't have parents. Nodes have parents, but not entities. So in this case, this model is the same. So in this case, I can go here to get translation. And from the model of this node that represents the light, and I get the matrix, and from matrix I get the translation, and I use it as light position. And the next thing I should always have pass about the light is the color. Okay, as I say before, the color is here. Well, it's a vector 3, but it's nice to have also the intensity in a separate variable. So I don't need to pass color and intensity to the shader and multiply it on the shader. I mean, the shader is never going to need to have them separately, and I can save some space on the shader if I put them together here from the C++. So I'm going to multiply them and send it to the shader. Okay, and it would be nice also to send the type of the light. So for sending the type of the light type, okay, it's this thing I put here, light type. But the light type, it's an enum. Enums have, well, there are specific. I mean, remember that an enum at the end is more like it's an integer, but because you put names of every possible value of the enum, is better for coding, for checking errors and everything. But in any moment you want to get the number, you don't care about that. You just cast it to the number and it's accepted. Okay. You want cast it to integer, and because it's an integer, it's okay. Okay. So we are casting the type to integer. The problem is from the shader, I cannot just compare it with light type point because this is a class from C++, not from the shaders. Okay. So this way I can know when I have a light from my code, the type. By the way, yes, I'm going to pass outside of this comparison because at the end, you're always going to need to pass these variables, no matter if it's a point light or not. So it makes sense to pass it outside. Maybe if the point light had a special property here, I can put it here. But yes, I think I'm being silly. I'm going to, yeah, and I don't have to put it inside here. So I'm passing the position, the color, and the type, okay, to the shader. And then I'm rendering the car. Cool. For the first iteration, it's going to render the car with these lights if we put it on the equation on the shader. The question is, what happens with the next iteration? On the next iteration, there are going to happen several things. First, the depth buffer will already have the car drawn there. If the depth buffer has the car drawn in that same position, then what is going to happen is it's going to try to render in the same position, and the depth buffer is going to say, hey, there's already something here, so you don't have to render anything here, and it's going to not render anything. To avoid that, we're going to say first that here that the depth function, which by default is less, because the depth function is what how has to be the z comparison to the z that's already written in a pixel to pass the depth. When you pass this test, means that it's valid. You have to draw it. If you don't pass it, means that this pixel doesn't have to be drawn. So by default means that you have to draw the pixels if the z is less than the z of the pixel it's already drawn. Okay, but I'm going to change it to lequal. Lequal is an abbreviation of less or equal. Okay, in OpenGL they decided to put it like this. So that means that it's going to render if the z is the same or closer to the camera. So in this case, because we're rendering the objects many times, it makes sense. And because I changed a parameter from OpenGL, always at the end of the function, I'm going to bring it back to the current to the default value, so I don't forget, and then because it will be wasting resources to have it modeless. It wouldn't crash the application or make anything weird on the screen, but you're wasting resources, so it doesn't make any sense. Okay, But remember that one of the ideas of the algorithm is that the first iteration we render the object, but in the second iteration we add it to the previous one. So because I want to control if it's the first iteration or the second iteration, I can put here an if the if is equal to the first iteration or the second one. But I will face a problem is because I'm skipping some lights. Maybe the first iteration is not the 0. Maybe the first iteration is the 2 or the 3 because the first lights I'm ignoring them. So if I didn't have this continue here, it will be work list 0 is going to be the first one, but because I have it, I'm going to do a hack, which is I'll render the light, so I render the first iteration, and then I'm going to switch here the blend function. I'm going to put to GL source alpha to GL1. This is the additive, and I'm going to enable GL blend. So maybe I put it on the opposite way, is more interesting. So first I'm going to say, okay, from now on, when you render, you have to add to the whatever you are doing. And here, this is the operation I want to do, the blending. So in this case, is take the color, the alpha of this pixel. So to take the color of this pixel, multiply it by the alpha. This the source alpha means multiply by its alpha, and then take the color which is already drawn on the buffer, on the screen, and multiply it by 1, and then you add them together. Okay. And that's it. I have already a system that is going to take into account multiple lights, at least if they are point lights. And if there was no point light, by the way, be careful, because if lights was empty, there was no lights on the scene, it would never enter this for loop, so it won't draw anything. Okay, so it's always nice to do something like, hey, if there is no lights in the scene equals 0, maybe I should treat this as a separate case. Like, I don't know, I mean, I'm going to render here the mesh, okay, but which shader? I'm rendering with this light shader, and this light shader expects to have a light. So I don't know what will happen, so maybe I should send a variable saying ignore the lights or something like that. For now, I don't have much time, so these are the kind of things I expect you to do, because maybe when I test your assignment, I remove all the lights to see what happens, and it doesn't show on the screen. I know you're doing something wrong, okay? So the C++ is more or less everything already good. Let's go to the shader. So I go to the shader, to my light FS. So I'm going to have some more variables now. I'm going to have one which says the light position and the light color. And also remember that we have that enum, which was an int, light type. So for me to remember, if type is 0, 1, or 2, what do they mean? It's always good to go to the light type. So it's light type here, and a light type. So here I can see the types. 0 means no light, okay? Point, spot, directional. Cool. I put here the no light because it could be useful if you don't want to send any light. In this case, you can send no light to light type, and then the shader knows that it doesn't have to do anything. So I'm going to try to remember these values. The best way to remember them is to put them written down. So I'm going to say, okay, 0 is equal to no lights, 1 is equal to point, 2 is equal to spot, and 3 is equal to directional. So I don't mistake it by any moment and write something different. Even if I want it, I can do something more like more professional and say something like no light is 0, and point light is 1, spotlight it's 2, and directional is 3. Okay, so now if I want to compare, I can compare with no light with point light, because in the other fine means that when you find this word, you replace it with this character or this text. Okay, so much simpler, much more beautiful. So now I'm going to have here, and in my shader where I have to compare, here I'm adding the MEC, blah blah blah. I'm going to add here how much light does it has. Okay, we were putting here the ambient light. So I'm going to say I need to know if this light type, what is the type? If it's equal to spotlight, no, sorry, point light. I'm going to do only the point lights now. Okay, then the only thing I need to do is, well, we have to compute what we did yesterday. No? We are going to compute the n.l, but for that I need the normal, so I'm going to have here the normal as n, which comes from the vertex shader, but it comes not normalized, so I'm going to normalize it. So I have a normal here, and and then I'm going to say that n.l is equal to the dot product between n and l. But for that, I need the L vector. And the L vector is going to be the vector that goes from this point to the point light. The point I'm drawing now, of the car, or the floor, or the house, to that specific point, to the light. I know where's the point I'm rendering now, which is here in wall position. And I know what's the point where is the light, which is in light position. So remember, when you want a vector that goes from one point to another point, you subtract the ending point by the starting point. So in the starting point here is, I want to from wall position to the light, so it's light position minus wall position. But I'm going to need this normalized, because all the vectors has to be normalized. Remember the trick I did yesterday, which is I can compute the distance of this vector by saying, hey, what's the length of this vector? And now I could do this normalize L, okay, and it will make the vector module 1. So I have how far it is and what's the vector normalized to module 1. But length and normalize are two functions that use internally as square root. And square roots are supposed to be super slow. I know that current GPUs probably are super fast in comparison with when I was started. But as they say that I'm doing 2 times square roots, which I don't need, because I know the distance of this vector. And normalizing is divided by the module, but I didn't really know the module. So if I'm a little bit smarter, I can do this, okay? And this is the same as normalizing. I'm taking a vector and dividing by his module. So that means that if it's module 100 and divided by 100, it's going to be module 1. So it's normalized, okay? So now I have the dot product. And because I have dot product, I can do the operation and say, hey, how much light this object is receiving? Yeah, the amount of light he's receiving, I'm going to add here the n.l, but remember that the n.l has to be clamped, okay, between 0 and 1, because I don't, 0 and 1, because I don't want to have negative light. By the way, you want to clamp. If you want to clamp a value between two values, like, in this case, if the normal is always module 1 and the light is always module 1, it's impossible that this is going to be bigger than 1. It's impossible. The dot product cannot be bigger than 1 if the modules are 1. It's going to be always between -1 and 1. If you not, you can save something. If instead of doing this, you say something like, hey, I want the maximum value between 0 and n.l, because I mean, you're never going to have to clamp beyond 1, okay? Because what I care is negative numbers. So in this case, I want to do the max between n.l, which could be negative, and 0. Be careful, because I see a lot of people when I was explaining this in computer graphics that when they say, oh, the value cannot be negative, I put absolute. Yeah, absolute is not the same. Remember, absolute means that if it's negative, it becomes positive, which is not what I want. What I want here is if the light is negative, which doesn't make any sense, then no light, it's 0, okay? So now we have this factor that says how much light do we have about this light, and I'm going to multiply it obviously by the light color, because, well, this is how much light reaches the object, but now I need to colorize this light according to the intensity of this light, okay? So that's it. I think I have the light position, the light color, and I'm using the light type, so the 3 variables and send, okay? I'm not taking into account the distance. I will add it later, so I can execute and see what we got. And let's see if there's no crashes on the shader. No crashes on the shader, that's a good thing. And I'm going to switch to my light mode, and boom, we have this, okay? It's not bad. I mean, it's true. You can see that here there's a lot of light. The lights are here. You can see point light here and point light here. And also you can see that if I go to point light and I move it around, the light is moving. So good. We are doing progress. We have 2 lights. And I can change the color. I can say this light is other color. But you can see how the light reaches even being far away. If I move the light very far away, it's still this light. Even if I'm going to take the other light and I'm going to disable it, and I'm going to go back to this light, and no matter how far away I put it, it's not the n.l is not going to take into account the distance. So in this case, it's going to be the worst solution. Also, keep in mind that if I hide this light by any reason, everything disappears, because I didn't take into account the possibility that there is no lights, okay? So always control. If there's no lights, I can call the function, and like as an example of how I can do it as a very simple way. 1 second. I can do something as simple as this. If there is no light, call send light type is 0. Okay, what's going to happen? If light type is 0, it's going to enter here, and when it reaches this position, light type is not going to be point light, so light is not going to be added. Okay, just by adding that specific use case, let me sure that I didn't do anything wrong. Mesh. Yes. So you can see if I execute this code now, I'm going, by the way, if you have one case where you have to switch every time something, don't do it that this way. You go to the code and just put it in the state that you want to work with. In this case, the state I'm working lights, so that by default it has to be this lights mode. Okay, so I have the scene with all the lights, and what happens if I remove this light and I remove this other light? Nothing gets rendered because that's weird. I was expecting it was going to enter the function. Okay, let's debug it because I don't like to leave this bug hanging around for some time. So okay, render entities, render node, yes, here. So light size is probably 0. So it's calling the mesh function, render triangles. I think so. So let's put a breakpoint here, execute it, and see what happens. Okay. So it's not entering the function. Well, as you can see, by the way, when you load it in the back, it takes a lot of time to load because textures take a lot of time to load. And in the back, it takes even more. I'm using multi-threading, by the way. My application loads the textures in another thread to at least be able to start application while the textures are being loaded. Because previous year, I wasn't using multi-threading. People was complaining that when they launch application, they have to wait a lot if they were in the book because textures take a lot of time to load, and the application won't start until all the texture has been loaded. So it was horrible. But now at least the geometry you have to wait, but for the textures not so much. Okay, so we have this scene, and if I switch this light off, okay, and if I switch the second light off, light size is not 0. Oh, I'm right. Light size is not 0 because there's other lights. There's the directional light and the spotlight. Okay. Well, then it's not a problem. I'm doing it right, but it's just because I'm skipping things that it's not lights. It doesn't make any sense. So let's keep going with the other lights and try to put everything here. Before I finish this, maybe it would be nice to have a little bit of attenuation because it doesn't look very beautiful. There's this kind of super light that reaches everywhere. So let's limit the distance, okay? We want the light that reaches us 0 distance. Lights has already a max distance. You have here this, it says 70. That means that I expect the light to reach maximum 7 units, okay? Every of this square, I think it's 10. So 7 should be like here, until here. 1, 2, 3, 4, 5, 6, 7, something like this radius. Okay, so how to do that? I'm going to pass the max distance also to the shader. It's not an int, be careful with this. And just so to let you know something about general culture about shaders, it's bad to send single number uniforms to the shader. So in this case, this is just one number. This is another one number. These are 3 and 3, which is good. But the thing is that shaders, at least as far as I know, when you store every uniform, it uses 4 floats. Every uniform is 4 floats. If you only use one, then the rest are just empty. So if you can pack more uniforms in one single variable, it's better. Like instead of sending light max distance, I can say light, I don't know, info, for instance, and I can say, okay, how many properties do I have in the light? If I go to the class light entity, there's a lot of properties here, and some of them are numbers like float, 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 okay? So maybe I can pack them inside one single one. So I can go here and say, okay, I'm going to send you a vector 4. Okay, the first parameter is going to be the light type. The second parameter is going to be the light near distance. And the third parameter is going to be the max distance. And the fourth one, I don't know. For now, I put 0, and maybe later I know what to put here. Okay, so this way, in one single uniform, I put more information, which is better because it's 4 numbers. As I was saying, all the uniforms are usually 4 floats. But also, I'm usually using this string once the access to the shader to know the location of this variable inside the shader once. So I'm saving a little bit of CPU time. I'm saving memory on the shader and I'm saving CPU on my side. So if we can save that data, always nice. Sometimes I pack even on the fourth component of position and color, I pack other information so I can use the blocks of vector for floats on this kind of information. So it's always nice to do this kind of things. Now that means that if I go here to my shader, be careful, I have changed these properties now. So instead of having light type, I'm going to have something more like light info, which is a vector 4. Okay, and I always put here a reminder that the first one is light type, near distance, far distance, and I don't know here. I put XXX because I don't know what it is. Okay, and because vector 4s are no longer integers, they are floats. Be careful, because if you try to compare now by light info, like here you say light type, light info dot x, which is the type, this is a float number, and point light, it was an integer number, so it's probably going to crash. So I'm going to try to cast this to integer. I don't know if it's supported by the shader like this, otherwise I can put here point light 0.0, 1.0, so I'm forcing that this is a float. Otherwise, when you compare integers and floats, shaders doesn't support that. They tell you no, you compare the same type or it doesn't work. Okay, so I haven't changed anything now, but I now have the far distance, which is max distance, which is the parameter. So I'm going to say that the amount of light, I'm going to multiply it by the attenuation. And this attenuation is going to be a number that is going to go from 1 when it's very close to the center of the light to 0 when it's in the max distance. The equation for that is on the slides. I don't remember now because I have to make some try and error to get it last time because I forgot to do it. And here is a ranged attenuation, so it's here. So you compare, you have the distance, and you say the attenuation factor is max distance minus light distance divided by max distance. Okay, so let's do that. It's max distance, which is light info z, minus the distance that we are having now, all this divided by this value here. So this supposed to be a very flat linear attenuation, which is not so bad. And because I'm multiplying this by this, that means that, let me check again that I'm not doing anything wrong. Here. I'm clamping it to it doesn't go negative, because if the distance is bigger than light max distance, you're going to make this subtraction negative. So you're going to have a negative attenuation, and that doesn't make any sense. So what I'm going to do here is say that the attenuation has always to be between 0 and whatever you want. If it's below 0, it's 0. It doesn't go lower. So we have attenuation already. Cool. Let's try to see if we have now attenuated lights, which should look way better. And we have it here. Okay, you can see these lights look much better. Okay, and I can select these lights and move them around, and you can see how the light follows. And I can make the light distance bigger if I want to have a bigger light or smaller lights. Okay, so cool. But imagine I have a very small light here, and another the other point light, I'm very small. Okay, I'm going to make a question, so be prepared, your minds. And this light is not reaching this house, and this light is not reaching this house. So this house currently is only illuminated by which kind of light? It's a very simple question, but I'm going to go farther from here. So why is this house illuminated if there's not, these 2 point lights are not reaching this house? Because the ambient light. Okay, thank you very much, David. Okay, but check this. If I disable this light now, oh, they become darker. Why? If this light is not affecting the house, why is when I switch this flag, it's switching the light? This is a common error everybody does every year. No ideas, no suggestions, no proposals. Check this here. If I go to this point light and I switch this off, it also changes the emissive. No ideas, because this is a very simple problem that you should check if you check the code at least. Here, what's going on? Nobody knows this problem. Come on. Let me show you the code of my rendering application. For every light, I'm rendering the mesh. For every single light, I rendered the mesh n times. And this is the code of my function that is going to compute the final color. And that final color is going to be added on top every time. So no ideas, really. How many times I'm adding the ambient light currently? If I have two lights, how many times I'm adding the ambient light? The ambient light for each light, two. Yep, twice. But ambient light and emissive light should only be added once because it's something not related to the number of lights on the scene. The ambient light and the emissive light is related to the object or to the scene itself. So it doesn't matter how many lights we have on the scene. The ambient and the emissive only once. And because I'm executing this code n times and rendering the mesh n times for as many lights, so the ambient light is adding. Okay? So how can we fix this? There's many solutions. I'm going to give you the crappiest one I usually use because I like it, which is I have uploaded already the ambient light here to the shader. After rendering the object, I say, fuck it, I'm not going to pass the ambient light. So I'm going to pass the ambient light as 0. Boom, just because if you add 0, it's going to be the same. And I'm going to do the same also for the emissive factor. It's not the best solution, but it works. So now by doing this, at least now when I render, it will look nice. But it's important that you do this kind of exercise, okay? It's very common for the students on this course to say, it looks nice. It keeps going. It never stops and says, wait. There's something weird going on. I take the light, I switch it off, and the house is changing the illumination, but that's wrong. It shouldn't. So what I'm expecting from you is that in your head, you're always trying to execute your own code. You're trying to deduce or to guess what's going to be the output of what you're coding and checking if what you see on the screen matches that. Because if what you see on the screen doesn't match what you are supposed to be getting, then there's an error. The problem is that most of you just see, okay, it's okay, and keep going. If it looks like light, it's light. No, it has to look like light and it has to look exactly like light. Okay, not just a little bit. Anyway, this is a very common error. I get people always loses points by these kind of errors by just putting things that doesn't make any sense to put the ambient n times. But anyway, so now we have lights. Like you can see here, I can move around. I can add more lights if I'll do Shift D. No, sorry, it's Shift D. No, Control D to duplicate. So I can add another light here. I don't know, let's put it like another color. And I can move it up. And it doesn't matter how many lights do I have. And I also can scale this light to make it bigger or smaller. Okay, cool. So we have a very basic light system. Super cheap, not very expensive. The only problem is obviously the number of calls I'm doing. Check here. I'm rendering 107. I'm doing 107 draw calls to the GPU. Okay, but if I duplicate the number of light, I take this light here and I duplicate it. So if there's one light more, okay, Control D, I'm increasing 40 draw calls, okay? And if I add another light, 40 draw calls. So for every object of the scene, I have to render every single object again, okay? So it would be nice to speed up this a little bit. So imagine this case, because it's important that you think about this. So I have here the car, which is very beautiful, but the problem is that there is no lights around here. There's only one light, which is here, and the max distance is this. So why do I have to render the car again for this light if it's never going to be touching this car? It would be nice to say, hey, I see that this car is so far away from the light that it's impossible. It's not going to have any light. How can we do that? Well, it would be nice to have a function to compare if this car overlaps with this light. And it is. I mean, we have the box of every mesh usually. Okay, we have usually this box, or if we compute it during the prior to the rendering. It would be nice to test if this sphere collides with this box. And that function is already on the engine. Okay. First of all, we will need the box. So where is the box? It's not here. We are not passing it. Remember when we call this function render measurement light, here we are computing the bounding box of this object, but we don't have it here. So because I would recommend you the day that you start doing the render calls, where you're going to pack all the render information in one structure, as it is on the slides of the first assignment. Okay, I don't know if I have put the slides of the first assignment on the web, but if they are not there, I will put them. Okay, I would recommend you to restructure this code so you are not sending node, model, material. You just send that this structure can render call, and that is going to have all the information necessary, like how far away, which material, mesh, model, bounding, whatever. All the information is there. So from the shader, you can say, oh, if this bounding is not touching this sphere, you don't need to. To test if the bounding is touching the sphere, in the math class here at the very bottom, we have operator to test things. And here is one which says, what does it say? Plane overlap, ray sphere, ray plane, ray bounding box, sphere overlap. Here, this one. You pass a bounding box, you pass the center and the radius of a sphere, and it returns true or false. True if they overlap, or false if they are far away. Okay, it's not very expensive. It's like you can see this function. It's not very expensive. You can see it's just a couple of comparisons and adding numbers and subtracting numbers. This here is squared value, and at the end it returns true or false. So as I say, super cheap. It can save you one full render call for every object, depending on every number of lights. So that saves lots of render time. But I'm not going to do that because I don't have time, and those are the kind of things that you do. I will give you points at the end of the assignment. Okay. So we have one light. Next light, we want to have directional light. Okay, directional light is that light that comes from the sky. Okay, cool. Remember that for directional lights, we don't care about the light position. It doesn't make any sense because the light, directional light, is supposed to come from the infinite distance, like from the sun distance. So passing the position doesn't make any sense. Will make more sense to pass the front vector of the light. Okay, so I'm going to add here another variable. Let's call it front vector, and this is going to be the vector that goes forward of the light. And we're going to use it also for the spotlight, so it's good to have it here. So where do we get this kind of vector that goes forward of the light? So I'm going to go here to the model, and the model has the rotation of the object, so the model should know what's the orientation. But there's a function here, rotate the vector, where you pass a vector in local space and it tells you this vector in global space. Okay, which vector it is? Well, the forward vector. The problem is, what's the forward vector? It's 001 or 00-1. We always say that in OpenGL forward is -1 in Z. So it should be 00-1, but I'm not sure if I keep the coherence on the data, so maybe I did it wrong. So let's start with 001. If it doesn't look right, I will put another one, okay? Because I remember that there was an error here, and I think that the light orientation was on the opposite direction. So anyway, I'm going to send this light front vector. So I can go here to my shader and say that we have a front vector. So if light is not a point light, but it's a directional light, okay, what do we have to do? Many things are very similar, but the L vector, I don't need to. The L vector is already comes from outside, so I can skip this part. Okay, so I can go directly to this. Also, the attenuation doesn't make any sense when we are talking about directional lights. They are infinitely far, so it's not like, depending on how far away they are, they should be smaller. So no attenuation. The only thing we care is that this light vector, now we have to compute it as the vector that comes from the front. So this is the L vector. Okay, as you can see, directional light is super simple, no attenuation. The end.L is very simple to compute. So now we have support for directional lights. Let's go to my shader, by the way, and to be sure that I'm taking into account if it's a point light. we are going to say if it's different of a point light and it's different from the directional light, then we continue. Okay. And now we are skipping the spotlights, so we are only using point and directional. So it crashed. It crashes because the shader has a problem here. It says I did something wrong here. Directional light. Directional light, and the variable was called. No, it was called directional. Ouch. I put light, but yeah, I'm going to put light because I want to keep consistency. So if I say everything has light, this one has to have light too on the name. Okay, it didn't crash. And now we have light. You can see that we have this kind of small light on top of the house, but not on the walls, because this light comes from the top of the scene to down. So if I switch off the spotlights, so we can see it better, I switch off this one and this one here. This and if I even remove the ambient light, which is here, you have to click here, scene, go to the ambient and put it to 0. You see this, we have this tiny illumination that comes from the ceiling and is illuminating the top, okay? And if I take this object, the moonlight, and I rotate it, you can see how I can rotate the illumination. Let me show you from the angle, maybe from here, how the light changes, and now light comes from the side or from below or from up, okay? Or even I can switch the light to comes from more from one side than from the other. Let me show you. Yeah, now the light comes from the left side, for instance. Okay, so as I said, very cheap to have, in this case, this light. So I'm going to put it back as it was. Okay, cool. And visibility of the 2-point lights. And okay, so last light we need to do is the spotlight. I put last because it's a little bit more complicated than the others, not very much, just slightly a little bit. So let's go to our shader, to our C++ code, and decide what we want to send. So we can get rid of this because we are going to send all of them. By the way, the light front doesn't make any sense to send it when it's a point light, so I can skip even this light if it's a point light, but it's super cheap, so forget about it. And I think that's all the information I need for the spot. No, sorry. No. For the spotlight, I'm going to need an extra data, which is for the light. I'm going to need. By the way, I have this track here. I forgot to remove this. But anyway, if you remove it now, it's going to crash because I use it in some places. But you don't need. Forget about this light data. It's something I did from to test. So the light also has this the cone. Where are the cone? Cone info. Okay, it's a vector 2. So here cone info has the minor distance and maximum distance. I already packed it in one variable because I don't want to have cone something and cone something. I don't remember now which one, the X or the Y is the max angle. Remember this cone, what's saying, if I have a spotlight which is pointed in this direction, I have an angle that defines the size of the cone. Okay, this is one of these two numbers, but indeed I have two angles because inside this angle, the cone weighted, so the factor will be 1 of the light, 1 and also multiplied by the n dot L, but outside of here is going to have a gradient that goes to 0. So it's going to be 1 here, but 0.5 in the middle and 0 here, okay? So it has this nice gradient on the sides of the cone that looks much more natural, okay? So for now, let's forget about the both values. I can just skip and use the first value. So how I'm going to compute the point light, the spotlight? What I'm going to do is I'm going to have this vector that's the front vector of the light, and I'm going to have a surface, and this light is going to have this beautiful cone, okay? And for a given point, imagine this point here, I'm going to have a vector that goes to this point, okay? This is the L vector, like the -1 multiplied by the L vector, okay? You can see like the L vector is this vector that goes from this point to the light, so this vector is the opposite, okay? So the question is, if I have these two vectors, what I want is if the angle between them it's below the angle of this, the half of the angle of this, sorry, because this angle here, let's put it like this. So while this angle is smaller than this other angle, the light should be the same. But when it's bigger, this angle, it means that this green vector is outside of the cone. And if it's outside, it should be 0, no light, okay? So how can we control if these angles are the right size? Well, the nice thing is you do the dot product, you get the cosinus of the angle, okay? Remember, when you do the dot product of two vectors, what you get of the dot product is equal of B is equal, if the both vectors are normalized, length 1 is equal to the cos of the angle, okay? So one option I could do is to say, okay, I'm going to send the angle, this value here, I'm going to send it to the shader, I'm going to do the dot product of these two vectors, but then I get the cosinus of the angle, not the angle, so then I would have to do the arccosinus of this angle to revert back to the angle, and because the arccos, which is the opposite operation, to get the angle, and then I can compare the angles. But doing cosinus and doing arccosinus is always very expensive. So if I'm smart enough, I can say, hey, instead of sending the angle, I can send the cosinus of the angle. If I send the cosinus of the angle, I only have to compare this number here by the cosinus of the angle I sent from the C++. It's very simple comparison, and it works perfectly. So I'm going to do that. I'm not going to send the angle, although here we have the angle stored here. What I'm going to do is I'm going to send the cosinus of the angle. So here in light cone info is going to be a vector 2 where I'm going to send first the cosinus of the first angle. So from here cone info x, I'm going to send the cos of this, and I'm also going to send the cos of the other one. Okay, so I'm saving a very expensive operation on the shader. Always good to do it. As I'm doing this for lights that are not cone lights, so it doesn't make any sense. I can save a little bit of doing two cosinus if saying only do this if this is a spot. If it's not a spot, you don't need to send the light cone. Okay, so now I can go to the shader and say, okay, besides all this information, you're going to also receive a vector 2, let's call it light cone. Okay, that contains here, always good to put reminders here, it has the cos of the mean angle. I don't know if it's the mean or the max, but I'm going to put here this. If it's wrong, I'm going to take a max angle. Okay, cool. So how I can solve this problem? You're going to see that the point light is the spotlight is very, very, very similar to the point light, with the only difference that it has an extra factor, which is the factor that tells you if you're inside or outside of this cone. So instead of coloning this again, which doesn't make any sense, I can be smarter and say something more like if it is equal to this or is equal to spotlight. But because these are too many comparisons, if you are smart enough, you can rearrange the comparisons and say something more like this. If it says a directional light, do something. If else is a point light or a spotlight, otherwise don't do anything. I was going to say you can remove this comparison, but there's also the possibility that the light is equal to 0, which means no light. So okay, I'm going to leave it for now. So I do everything exactly the same, compare everything, attenuation, blah, 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 blah. But here I need to compare if this point is inside or not inside the cone, okay? To do so, I need the front vector, which I have it. I need to compute the dot product of the front vector with this minus L vector, which is the light vector, but in the opposite direction because I want to align both of them, okay? And this is going to give me a number between 0 and 1, or sorry, between minus 1 and 1. And then I want to be sure that only if this value is smaller is going to take into account. So if this value is smaller than the cone angle, in this case, dot x means it's inside the cone. If it's inside the cone, everything goes well. Otherwise, if it's outside of the cone, what I want to do is I want to say that attenuation is equal to 0. Okay, think about it. If the attenuation is 0, when you multiply 0 here, it's going to cancel the light. So I'm forcing now that it has to be inside of this. Okay, I'm not taking into account the other value for now because I only care about one. Okay, the other one I would put it now to make it more beautiful. So let's see what we have here. We have some sort of a spotlight. Something is not going well. Let's move this out. Yeah, this is wrong. It's wrong because this is totally spotlight. And I can say if you change... Oh, no, you change this. Oh, yeah. I remember what it is. Sorry. This is a super common error that all the programmers, we always do, which is that cos functions need radians, and this is in degrees. So, decturrad. Always be careful with angles because it's very common that we like angles in degrees because it's easy to understand degrees for you as a programmer, but cosinus and functions and trigonometric functions they expect to have the other one. Okay, so I have the light, but I can see something strange here, that the light is in the opposite direction. Okay, if I go here to the spotlight and I change the cone start, is in the opposite. I was expecting something like this, but I'm getting something like this. So there's two things wrong here. First, the vector, I think it's this vector has to be in the opposite direction. So I'm going to switch it. Like I know it's kind of ugly, but I'm going to remove this L here. I think it's opposite. It's going in the opposite direction. The vector, the front vector. Okay. Now I have a spotlight that casts darkness, which is very cool, but it's not what I want. I'm doing the opposite in the comparison. It should be smaller than this one. Sorry. So I don't know why. It doesn't make much sense what I have done, but now we have a spotlight. Okay, and you can see that I can select the spotlight and move it around. Okay, and the light behaves like a light. And if I rotate the light, I take this and move it around, I have a spotlight. But as I say, the problem with this spotlight is super harsh, the edge. You can see this edge is, it's like cutting the scene. It would be nice to have two edges. One is internal, one outside, and there's a beautiful gradient between both of them. Okay, and you can see here if you point at here how sharp this is. Okay, so that's why we have two values. So what I'm going to say is, if it's outside of this one, it's 0. If it's outside of the second one, okay, then it's part of this gradient. We will have to compute the gradient here. Let's put it like 0.5 for now. You will see how it looks like. Otherwise, it's going to be the same. Okay, so by doing so, no, it's not what I was expecting. Sorry, I did it in the opposite. I should say first is con E and then con X. Let's reload it. Yeah, you can see now. Okay, so if it's smaller than the second the max, this is the max angle. Sorry, so the first y is max and other is mean and max. Yeah, I did it right. Okay, so if it's smaller than this, means that it's outside. Okay, if it's smaller than the second one, but I have passed this if, so it's in the middle of both values, so it's 0.5. Otherwise, it's the same. Attenuation is 1 because it's the, well, not 1, but the one that came here. By the way, it shouldn't be 0.5, it should be 0. Multiplied by 0.5 because I want to keep the other one. Okay. Okay. But 0.5 doesn't make any sense. It would be nice to have here some linear gradient. Okay, and for the linear, I want to know how much difference we have between these two values. Okay, and I have this here on the slides. Let me go to the spotlight here. Here you have this same operation, the max angle and param blah blah blah. By the way, this is horrible because I put max angle here and I param z here. I forgot to change this to mean. I will change later. Well, I can change it now. So this is mean angles cos. Mean angle cos. Okay, so I can do this operation. What I'm going to do now. So let's go back to my shader, and I have here my code. It's always nice to put it here and here, so I can have it more like this. And I'm going to no. Where is my here? And this is going to be here. Yeah, sorry. What? If you put it full screen, it doesn't allow you to do it the split screen. That's annoying. Anyway, I'm going to put it here. Okay, so I have here my code. I'm going to put it like this so I can see it better. And I have here my function. So I'm going to say instead of this, what I have to do is say, is the cos angle that I have computed previously, which by the way, I'm doing twice. This is very silly. I'm going to do it once. Cos angle is the cos angle minus the minimum angle, which the minimum is x here, divided by the difference between the two. So the difference between the two is max divided by, oops, the biggest one is it's y minus the smaller one is x. Okay, so now I'm making a gradient. So let's try it. I go here and reload. I did the opposite gradient. You can see it goes from maximum to minimum. I can invert it very easily, putting 1 minus here, which is, I mean, I should rearrange the values. I didn't rearrange it correctly, probably, so damn it. So here you have now a beautiful gradient. And the nice thing about this gradient is that if I go to the editor now and I select here, I can control how much I want for every gradient. So I can control both angles, so it looks more beautiful, okay? Maybe it makes more sense instead of having const start and const end to have const start and const range to say how much angle does this range has. But anyway, I put it like this because it makes more sense, okay? So we have already our beautiful scene where we have spotlight. No, we don't have spotlights. What happened to the spotlights? Oh, yeah. Yeah. I did something very silly here. I'm doing this even when the light, it's a point light, but I only have to do it with its a spotlight. Okay, and there we have it. We have a scene with 2 point lights, 1 spotlight, 1 directional light. By the way, directional lights, we are always going to have only 1, so it doesn't make much sense to have like support more than 1, but in this case, it's okay. And the scene, I think it looks a little bit better. And always we can go to our previous one to see how dead this looks comparison to this one that looks more like moody, okay? So you saw it today. It's like 10 minutes after the limit time. There's more things that you have to do. You can see I did most of it. So there's more things that you have to do. Here I'm going to show you things that so you remember. You have to do this also in single pass, not only in multipass. I would recommend you to make separate functions for multipass and single pass, so you can control if I want to use single or multipass. Like there's a flag to control it. That would be nice. And also, I didn't use the occlusion texture. You have to use it, so you better send the occlusion texture to the shader. More things. I didn't do any optimization of checking if the bounding box of the lights collide or not with the bounding box of the objects. So you have to do that using spheres for lights and boxes for the meshes. Keep in mind that for the spheres make sense for the point lights, and for the spotlights not so much, but you can use spheres for the spotlights. For directional lights doesn't make any sense. Directional lights affects all the objects, so you cannot skip them. You all have to do them. Okay. Different kinds of attenuation. I did put here like attenuation factor, like you can control it sometimes the range of attenuation with some factors if you want to play around with different kinds of attenuation. Maybe you want to play around with this. And I also expect that you add the normal maps. So you are sending the normal maps to the mesh that has a normal map and some sort of flag to say, hey, there's a normal map, so you have to use it, because that will improve a lot the cars and you have to check that it looks nice. Okay. And I think that's it. You have here the code by the normal maps, by the way. And this, you don't have to do this. We will talk about this maybe on the next week. Okay. And maybe you also want to add specular. If you want to add specular, which is very simple, you remember from the previous the computer graphics course, is just doing another extra operation besides the n.l. keep in mind that you need to know how much specular every material has. And to do so, remember that you have the information stored on the texture, okay? On the material here, we have values here that specify the metalness and the roughness. These two parameters are the equivalent of the shininess and the specular factor of the specular model that we used on the computer graphics. So you have the values. And if you're going to use these values, keep in mind that these values are going to be modulated, obviously, by the texture. So there is one texture here called metallic roughness, which it's a bit bad because it should be occlusion metal roughness, okay? Because the first channel, the X channel, is the occlusion, the metalness is the second channel, and the roughness is the third channel, if I'm right, okay? So it would be nice that you read this texture and you pass it to the shader and you use it on the shader, okay? So you add a specular. And for maybe thing that you do, the render calls, it's and the sorting of the objects according to distance and rendering the alpha objects after all the opaque objects, you get 2 points, I think. Then single and multi, 1 point for every one of them. Normal map, another point. What else? Specular, another point. And yeah, and I don't remember. The other things was if everything was working, if the code is clean, stuff like that. Okay. It's important that for the first assignment you try to make the code as clean as possible because you are going to need it for the next assignments. So you better start making your code clean and restructuring everything. And you have to put middle functions to do steps that you're going to do many times. It's always nice to do them. Okay. So I think that's it for today. Thank you for staying here. And if you have any doubts about the class of today, please send emails. Please talk to me on the Discord, which by the way is super dead lately. And so it would be nice that you put more questions about it. And also, you want to share screenshots about what you're doing on the main channel. It would be nice. People love to see always what other people is doing. Okay. So that's it for today. If I have checked, no, I haven't checked the news. Sorry, I will check now. Okay, I got it. So you know, no more questions. Nobody wants to know more. It's important that if you find any strange behavior on the engine, let me know today or tomorrow because I mean now we have to fix the engine. Otherwise, it will be more painful for all of you. So anyway, thank you for coming. See you. Remember that next week I will be on Monday, but I won't be the other days. So have a lot of questions for Monday if you want to solve them. Okay, bye everybody.